So we all know the AI revolution is in full swing, right? But what if I told you it's about to hit a massive wall, a trillion-dollar bottleneck that almost no one is talking about? Well, today, we're going to dive right into AI's biggest and most expensive blind spot.
You know, for the last few years, it's been all about large language models. We've taught machines to speak, to write poetry, to code. They've pretty much mastered text. But the real next frontier, the next giant leap, it's not about language anymore. It's about vision. It's about teaching these machines to actually see and interact with the physical world around us.
And here's where it gets really interesting. What if the very foundation of how we're teaching machines to see is just wrong? Like fundamentally broken from the start? That's the huge question we're going to unpack right now.
All right, let's get into it. The entire industry is shifting gears in a big way. We're moving away from AI that just crunches text and towards what people are starting to call physical AI. We're talking about systems that can genuinely perceive and understand the real world.
And it's not just a fringe idea. You've got heavy hitters like Jan LeCun over at Meta basically saying that for AI to get any smarter, it has to learn by observing the world, not just by reading Wikipedia. And that means it needs to drink from a fire hose of visual data constantly.
And this chart, it tells the whole story. Just look at those projections. The blue bars there, those are the AI models that can see, that can process video. They're not just growing, they're absolutely set to explode, leaving the text-only models in the dust. So yeah, vision isn't just a nice-to-have feature anymore. It is the future of AI development.
Okay, so here's the situation. We're building these unbelievably powerful AI brains, right? We're pouring literally trillions of dollars into the hardware to run them. But there's a huge, huge problem. It's like we've built a Formula One engine, but we've hooked it up to the wheels of a tricycle. We've given AI a supercomputer for a brain, but its senses are just slow, clumsy, and wildly inefficient.
Get ready for this number because it's pretty wild. 30 to 60%. That's how often those super expensive, power-guzzling GPUs, the engines of the whole AI revolution, are just sitting there, doing nothing, just waiting. Can you imagine the waste? The sheer amount of money and energy just going down the drain?
And this problem actually has a name. They call it GPU starvation. Think of it like a massive traffic jam on the highway to the processor. The car, the GPU, is incredibly fast, but it's stuck because the road is clogged. The bottleneck isn't the compute power anymore, it's the data pipeline itself. We just can't feed the beast fast enough.
And just to give you a sense of scale here, check this out. Over 80%. That's how much of all the data flying around the internet is visual. Video, images, the whole shebang. This isn't some niche data type. This is the fuel that this next generation of AI is supposed to run on. It's almost all the information out there.
But here's the crazy part. Even with this absolute ocean of visual data available, we're analyzing less than 1% of it with AI. Let that sink in, less than 1%. And it's not because the data isn't valuable, it's because our systems, our entire infrastructure, just chokes when trying to handle it.
So you gotta ask, where is all this inefficiency coming from? Well, it turns out it's a deep, fundamental flaw in the system. It's almost like a hidden tax that we're paying on every single operation. Let's call it the retrieve all, decode all, and then discard most tax.
And this, right here, is the absolute heart of the problem. It's a total architectural mismatch. You see, formats like JPEG, they were designed for one thing, showing a picture to a human being, on a screen, linear, top to bottom. But an AI doesn't look at a picture like we do. It needs to analyze tiny, specific pieces of it, often all at the same time. We're essentially trying to use a paintbrush to perform brain surgery. It's just the wrong tool for the job.
And let me walk you through just how painful this tax is. Let's say an AI just needs to check a tiny detail. Step 1, the system has to retrieve the entire giant 4K image file from storage. Step 2, it uses a precious CPU power to decode every single pixel of that massive frame. And then, step 3, after all that work, it literally throws away more than 99% of the data just to get to that tiny little bit it needed in the first place. It's just insane when you think about it.
Okay, so how on earth do we fix this mess? Well, the solution is actually pretty elegant, and it's not what you might think. It's not about building even faster chips. It's about creating smarter data. This is where a totally new idea comes in, the compute-aware data format.
The core concept is actually simple, but it completely flips the script. Instead of just throwing more horsepower at the problem, what if we made the data itself intelligent? What if we structured the data file in a way that's designed for a machine to read it, right from the very beginning?
So here's a taste of how it works. Imagine a data format that's built like a pyramid, with different layers of detail. An AI can start at the top, grabbing a super small, low-resolution version of the image, just the big picture, to get its bearings. It can instantly see, okay, I'm looking at an airport with some planes. And then, and this is the magic part, once it knows what it's looking at, it can dive down and request only the super high detail pixels for the specific spots it cares about. It doesn't have to decode the whole sky or the entire runway. It's genius, really. It's all about grabbing just as much as you need and no more.
All right, that all sounds great on paper, but you're probably thinking, does this actually work in the real world? Well, let's look at the numbers. Because honestly, the results are nothing short of a revolution. This isn't a small improvement, it's a total game changer.
First up, raw speed. When you take a compute-aware format, like VC6 for example, and run it on a modern NVIDIA GPU, you see these just massive, order-of-magnitude speedups. Why? Because the format is built from the ground up to be processed in parallel, which is exactly how a GPU likes to work. It's a perfect match.
Okay, but what about a real live production setup? This is where it gets even crazier. Compared to the normal uncompressed standard you'd see in broadcasting, this kind of format slashes the network bandwidth needed by a mind-blowing 93%, and it cuts the total time it takes for an AI to do its job by almost 80%.
I mean, just look at this table. It really puts it all in perspective. Forget bandwidth for a second and just look at the latency. We're going from 1.5 seconds down to about 300 milliseconds. That is the difference between a system that's just reacting to the past and one that's operating in true real time. That's not just a step forward, that's a whole new ballgame.
So, what's the big picture here? What does this all mean for the future of AI? Well, by finally getting rid of this massive data bottleneck, we're basically unlocking a whole new universe of AI applications. Stuff that was just a pipe dream before because it was too slow, way too expensive, or frankly, just impossible.
We're talking about things like instant replays in live sports that are actually, well, instant. Like under 2 seconds. We're talking about being able to search through massive video archives on the fly without waiting hours for proxy files. It means we can train our AI models faster and cheaper. It means we get smarter robots, better drones, and autonomous cars that can finally react to the world as fast as they need to.
So here's the bottom line. The winners in this next phase of AI, it's not just going to be the folks with the most powerful computers or the fanciest algorithms. The real winners will be the ones who figure this out. The smartest models need the smartest data. It all comes back to the data. Which really just leaves one last question for you to think about. Is your data compute aware?